Hi, I'm Matt, and in this video we are going to go over identifying organic functional groups. This video is part 1 in 2 videos on this, and in this video we are going to go over some of the simpler, more commonly seen functional groups, and they are listed in the description of this video. Before we start identifying functional groups, it's important to look at what a functional group is. So a functional group is what organic compounds are sorted into so that they could be easily studied. In an organic molecule, it is the functional group that determines the molecule's chemical properties. While the carbon framework, or the chain of carbons the functional group is attached to, does play a role, it is the functional group that plays the key role in determining its properties. So for example, in 1-propanol, it is the OH group on the end that determines the properties, and less so the free carbons it is attached to. And based on this, compounds in the same functional group have similar chemical properties. So 1-propanol and 1-butanol both have an OH group, so they will have similar properties to each other. In this video, there are 5 types of functional groups that we are going to talk about. The first group contains hydrocarbons, which are functional groups that only contain carbon and hydrogen. Then there's halogenoalkanes or halocarbons, which are functional groups containing a halogen in addition to carbon and hydrogen. Functional groups where oxygen is single bonded to a carbon. Functional groups containing nitrogen. And then carbonyls, which is a functional group where an oxygen is double bonded to a carbon. And the last thing to talk about before we get into the functional groups is just some notation throughout this video. So in the structural formulas shown, an R is going to represent a chain of carbons or a hydrogen. It just shows how what's there doesn't really matter and isn't part of the functional group. If there are multiple carbon chains attached to the carbons in the structural formula, there will be multiple R's. They are not necessarily the same chain. So just because you see 2 R's, you can't assume they are the same chain. And then, in some of these structures, there would be resonance between the functional groups. Only one resonance structure is shown for simplicity. So moving into hydrocarbons, the first functional group we are going to talk about are the alkanes. As hydrocarbons, they only have carbon and hydrogen, and they can only have single bonds. Since they only have single bonds, carbon and hydrogen, it could be determined that the amount of hydrogens is equal to twice the amount of carbons plus 2, as shown in the formula CnH2n plus 2. And a good example of an alkane is hexane. The next functional group are the alkenes. They also only have carbon and hydrogen, but they have a double bond in addition to single bonds, as can be seen in the structure. Since they now have a double bond, the formula for the amount of hydrogens is that the amount of hydrogens is equal to twice the amount of carbons. And a good example of this is 2-butene. And the last type of functional group we're going to talk about in the hydrocarbon category are the alkynes. They have a triple bond in addition to single bonds. Therefore, they have the formula that the amount of hydrogens is equal to twice the amount of carbons minus 2. And a good example of an alkyne is 3-hexyne. The next type of functional group we are going to discuss are halogenoalkanes or halocarbons. That is the functional group itself, as there is no other real functional group that's similar to this one. So a halogenoalkane is a compound where one or more of the R groups on the carbon is replaced by a halogen, that being a group 17 element, such as fluorine, chlorine, bromine, and iodine. So instead of the R in the structure, we replace it with an X, as seen below. And a good example of this is 2-chlorohexane, where instead of a hydrogen or a carbon, a chlorine is present. The next class of functional groups that we are going to talk about are functional groups where oxygen is single bonded to a carbon. The first type is an ether. This is where an oxygen is bonded to 2 carbon atoms, almost like a sandwich. Looking at the structure, we see that the oxygen is in the middle. It doesn't necessarily have to be in the middle of the molecule, but we see it's connected to two carbons that are connected to either hydrogens or other carbons. And a good example of this is 1-methoxypropane or methylpropyl ether, where the oxygen is connected to the CH3 on the right and connected to a chain of carbons on the left. The other type we're going to talk about in this section is an alcohol. This is a compound where a carbon is bonded to an OH group. In the structure, we see that there's a carbon with either carbons or hydrogens coming off of it, attached to an O that's directly bonded to an H. And an example of this would be 2-butanol. Another type of functional groups are those that contain nitrogen. In this video, we only have one, but in part 2 there will be many others. The most important group containing nitrogen is the amine group, and this is where a carbon is connected to a nitrogen atom. So if we look at the structure, we see that there's a nitrogen that's attached to two R groups, either hydrogens or carbons, and then the nitrogen's also connected to a carbon. And a good example of this is ethylamine, where the nitrogen is connected to two hydrogens and then also connected to a chain of two carbons. The last type of functional groups that we're going to talk about are those that have a carbonyl, or a carbon double bonded to an oxygen. The first type of functional group in this class are the aldehydes. This is where a carbon is double bonded to an oxygen and is also connected to a hydrogen on one side and an R group on the other side, such as in ethanol. It's important to note that there's an hydrogen and not two R groups, because if there was two R groups, this would be a different functional group. That leads us into ketones, where it's a carbon attached to two R groups and double bonded to an oxygen. As you can see in the structure, it's very similar to that of an aldehyde, except that it has two R groups instead of there being a hydrogen. And a good example of this is propanone. The next type we're going to talk about, and probably one of the most important, is a carboxyl or an organic acid. This is a compound where a carbon is double bonded to an oxygen and is also connected to an OH group. That has to be from the same carbon connected to both oxygens. And a good example of this is butanoic acid, where it's a chain of 4 carbons where the last carbon is double bonded to an oxygen and connected to an OH group. The next type is an ester. This is where a carbon is double bonded to an oxygen and single bonded to another oxygen, but that oxygen is then connected to another carbon. Esters are similar to carboxylic acids, except that they differ that instead of an OH group, there's an OR group connected to the carbon, such as an ethyl ethanoate. And the last type we're going to talk about is an amide. This is a compound where a carbon is double bonded to an oxygen, and that same carbon is single bonded to a nitrogen, as seen in ethanamide, where there's a chain of 2 carbons, and on one side that carbon's connected to an NH2 and double bonded to an oxygen. Now that we've gone through multiple functional groups, here are 4 practice questions to test your knowledge of them. Question 1. Which of the following groups does not contain an oxygen atom? An amide, an amine, an alcohol, or a ketone? Question 2. Which of the following groups is not classified as a hydrocarbon? Alkane, alcohol, alkyne, or alkene? Question 3. Which of the following elements would cause the structure on the right to be classified as a halocarbon? That would carbon, nitrogen, iodine, or oxygen have to be the element represented by the X? And the last question, which of the following groups does not contain a carbonyl or a C double bonded to an O? A ketone, an ester, an ether, or a carboxylic acid? At this time, I suggest you pause the video and the answers will be provided to you on the next slide. The answers are as follows. For question 1, the correct answer is an amine, as there is a nitrogen but there is no oxygen present. For question 2, an alcohol is correct because it is not a hydrocarbon as there is an oxygen present. For question 3, to be a halocarbon, there has to be a halogen present, and the only halogen in the choices is iodine. And for the last one, a ketone, an ester, and a carboxylic acid all have a carbonyl in them, and ether only has a single bonded oxygen, and that is why it is correct. Hopefully you got these. If not, feel free to leave any questions you have in the comments below, and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.